They build big street in very limited time with robots and AI only without people, and that's how this done, bro. They built an entire road in China in an extremely short period of time, using only robots and artificial intelligence. This was done without human workers. No laborers, no voices, no breaks for food. If it succeeds, countries will be able to build cities at double the speed. If it fails, you are left with a mistake embedded into the ground. The dawn of a highway built by machines. When the sun rose over the highway, no workers appeared at the construction site. Instead, machines stood silently, their metallic surfaces reflecting the first light like armor. Then, almost as if on command, they began to move smoothly, in synchronization, methodically. From a control center several kilometers away, a small group of engineers watched in real time as sensors, satellites, and algorithms replaced human instinct. The leading paver moved forward, its heated screed laying asphalt into a flawless black ribbon. Behind it, road rollers followed in geometric formation, compressing the surface with surgical precision. This was the first fully autonomous asphalt paving operation in the world, an entire highway built without a single shovel lifted by a human hand. The project, led by heavy industry engineers, was more than a demonstration of robotics. It was proof that infrastructure could now think, adapt, and correct itself. And as the machines worked through the morning haze, their silent efficiency raised a question larger than the technology itself. If roads can build themselves, what happens to the people who once built the world? The robotic convoy moved in perfect choreography, one paver in front, followed by massive rollers in flawless alignment. From above, they no longer looked like construction vehicles, but like a living circuit flowing across the land with mathematical grace. At the heart of the system was an autonomous paver designed to operate without direct human control. Its sensors mapped the surface millimeter by millimeter, adjusting temperature, pressure, and they were guardians of their own obsolescence, watching machines perform what once defined their careers. This was supervised autonomy, the point where human judgment meets robotic precision. The site was silent, but not empty. Every rotation, every vibration, every centimeter was measured, analyzed, and archived. Once safety was assured, precision became the new frontier. The question was no longer whether machines could work safely, but whether they could work flawlessly. In traditional road construction, there was always a telltale sign of the human hand. Edges were difficult to compact perfectly. Tiny gaps formed near curbs, imperfections that grew over time into cracks and erosion. These reduced the lifespan of roads by years. Autonomous rollers changed that. Using edge detection algorithms guided by high-resolution sensors, they followed the exact contour of the road with millimeter accuracy. Each pass was calculated, each overlap measured. There were no weak joints, no overcompressed zones. The result looked unreal, like glass poured onto the earth. Engineers called it zero-edge compaction, a quiet revolution that proved machines could not only replicate human skill, but surpass it, achieving uniformity impossible by hand. But perfection came with consequences. The same precision that eliminated defects began rewriting the economics of construction. When the final section was completed, there were no speeches or ribbon cuttings. Data was analyzed instead. Labor requirements dropped dramatically. Fuel consumption fell significantly. Surface uniformity exceeded all manual benchmarks. What once took weeks was now done in days. For the engineers, this was not just automation. It was standardization at national scale. Every measurement from the project fed into a central database, refining algorithms that would soon guide projects across the country. Economists saw the implications immediately. Infrastructure costs in developing regions halved. screed temperature, asphalt viscosity, layer thickness, compaction density. If the paver detected a weakness in the base, it automatically adjusted its angle. If a roller sensed uneven pressure, it increased force by tiny increments until perfection was achieved. Precision was not a choice. It was the mission. Satellites guided each machine with extreme accuracy, allowing massive vehicles to stop within a margin smaller than a coin. Even minor variables like humidity and surface reflection were factored into the model. Where humans once relied on experience, sound, and visual cues, these machines replaced instinct with measurable truth. Yet this was not magic. Every decision was built on thousands of hours of human engineering. Algorithms were trained on the muscle memory of workers and operators who once performed the same tasks by hand. The machines did not erase them. They absorbed generations of knowledge into code. Inside the control room, engineers watched streams of data across dozens of screens. Pressure graphs, compaction maps, thermal traces. There were no alarms, no interventions. The convoy moved continuously, every correction invisible, every calculation exact. What they were witnessing was not merely automation. It was awareness, mechanical instinct born from data. For the first time, a highway was not just being built. It was being understood as it came into existence. Safety was not an afterthought. It was built into the architecture. Each machine carried an invisible electronic boundary that halted operations instantly if something entered its path. Radar, LiDAR, and optical sensors scanned continuously, recalculating routes in milliseconds. If one vehicle stopped, the rest adjusted automatically, preserving the formation. From the remote control center, engineers monitored digital twins of each machine in real time. One click could stop the entire convoy. That click carried weight. They were not just supervisors. Always depended on labor and logistics. Remove those variables, and the equation changes entirely. China now had a reproducible model. Fleets of autonomous machines working continuously, monitored remotely, delivering identical results across vast regions. For a country investing heavily in global infrastructure, the strategic potential was enormous. Each meter built was not just road. It was proof of a system that could scale beyond borders with only a software update. The news spread quickly through engineering circles worldwide. Footage reached boardrooms in Asia, Europe, and North America. Other nations began experimenting. Pilot programs launched. Research funding increased. But while others studied, China scaled. Autonomous systems were adapted for tunnels, bridges, and dams. The machines did not just build faster. They collected performance and environmental data that trained the next generation of models. Each project made the system smarter. This feedback loop created a decisive advantage. While others debated standards, testing frameworks, and legal responsibility, China was already laying new ground. Autonomous construction was no longer just innovation. It was geopolitical leverage. A nation that could build infrastructure faster, cheaper, and safer did not merely win contracts. It shaped trade routes, timelines, and industrial standards. In a world racing to rebuild for a changing climate, whoever mastered machine-built infrastructure would not just build the future. They would own it. Yet beneath the asphalt lay a deeper question. What happens when creation no longer requires its creators? For most of human history, progress was measured in calloused hands. Every road and bridge was a monument to human labor. The autonomous highway told a different story. A world where creation no longer demanded human presence. The machines continued, but the human imprint remained. The algorithms were built on centuries of intuition. The screed angle in real time. The machines behind it followed through digital synchronization, each calculating its own path based on the data sent from the lead unit. The formation had a name. One paver followed by rows of rollers, each responsible for a different stage of compaction. The first compressed the asphalt while it was still soft. The second stabilized it. The last sealed it, creating a surface smoother than any human crew could achieve. What made the process remarkable was not just automation, but cooperation. Each vehicle was connected via satellite systems, communicating with centimeter-level precision. A single miscalculation could have ruined the formation, but it never happened. The system functioned like a single mind spread across multiple bodies. From the control room, operators did not drive or issue voice commands. They watched silently as the convoy constructed a multi-lane highway at a pace no human team could match. Every completed meter was not just asphalt, but data flowing back into the system to improve the next operation. China called it autonomous construction, but to those watching the machines glide through the mist, it already looked like something more. The first coordinated act of a world building itself. Inside the control center, one engineer whispered that it felt like watching his hands move without him. He had spent years paving roads by instinct. Now that instinct had become an algorithm. Beneath every stretch of the new highway, an invisible intelligence was at work. Each machine was not simply following a script. Cameras scanned surface texture. Sensors measured heat loss. Pressure plates detected the slightest subsidence. Data streamed continuously into onboard computers that analyzed, adapted, and learned in motion. At the core of the system was a fused sensory architecture, combining GPS, radar, thermal imaging, and LiDAR into a single stream of environmental awareness. Every parameter was monitored. The difference now was permanence. Knowledge was captured, digitized, and multiplied. When the final stretch cooled under the afternoon sun, no one returned to the site. The machines shut down. The data did not. Every meter fed a smarter model. Every pass became stored knowledge for the next road, the next city, the next country. The control room did not celebrate. It reviewed. The code kept learning. And somewhere, a retired road worker watched the footage and whispered, "We used to do that." The age of autonomous construction did not arrive with applause. It arrived with a file download. If machines can build the ground beneath our feet, who decides where they go next? If you like video, push button of like and do subscribe. We see next one, my people.